Okay, so running atomic transactions across multiple data models and a few marks and even an exclamation mark. So is this even possible? Well, my name is RedisGraph. I'm a bioinformatician, but now I work as a developer advocate at Redis Labs. You can find me on Twitter at Croloris. I also blog at christoph.it. I'm also the host of a show on Twitch called Zig Show, which is a show for the community of a programming language called Zig. It's a new upcoming language. It's pretty interesting. But let's move forward with our talk. So a couple of slides about my company. So I work for Redis Labs. As you can imagine, Redis Labs is the company behind Redis. And Redis is an open source in-memory database. It's famous for being fast. It's used for caching. Historically, it has been used for caching a lot, but also a few new use cases are starting to pop up. And that's the reason of my presentation here. I assume that you probably, if you are here, you probably know about Redis a little bit, but it's fine even if you just know the name and you only used it for caching. So I'll give you a little bit of a introduction to it during the presentation. So another interesting thing is that the company Redis Labs supports the open source development of Redis, but we also have, so how do we make money? We sell Redis Enterprise, which is it's open source Redis plus some extensions on top that help enterprises make the most of Redis. And we recently announced a partnership with Microsoft and Azure. So now if you soon you will have the possibility of having Redis Enterprise managed for you by Redis Labs through Azure, so unified billing and everything else, and it will show up as one of the high tiers of Azure Cache for Redis. So that's pretty exciting stuff. Also, if you're not an Azure user, but if you use Google Cloud, we are also partnered with Google. On the sidebar of your Google Cloud console, you will find at the bottom, among other partners, so there's also Redis Labs. So you will be able to also there spin up Redis Enterprise instances managed by Redis Labs and unified billing and everything else. Also, you can see on the right side that there's a QR code. I will show throughout the talk a few links that might be of interest to you. So if you think it might be useful, keep your phone out in case you want to take a picture of the QR code. So yeah, where was I? What were we talking about? Atomic transactions across multiple data models, which kind of sounds like a fairy tale, right? You are used to thinking of different data models as different databases, different services, different universes almost, and running atomic transactions across all this stuff doesn't seem really to be possible. But I'm here to say that no, it's true, all of it. You can do it. Otherwise, this will be a very boring presentation. But let's dive into the story then. So in 2009 in Sicily, Redis was created. Yeah, this is the one animation I have on the whole presentation, so don't worry, we got past that. This is an interview by Matt from AWS, who interviewed Salvatore Sanfilippo, also known as Antirez, the creator of Redis. And it's not too long of an interview. I think it's very nice because it's short and it gives you a good overview of where Redis comes from. So the idea is that Salvatore wasn't a database guy at the time. He wasn't somebody that worked for Oracle. So that's why when he created Redis, he broke away from many of the assumptions that were present in the database scene at the time. Nowadays, it sounds less radical because now we have NoSQL and we have a now non-SQL databases have become a thing. But at the time, that was very much anti-database establishment as you could get, I guess. But that said, even though Salvatore wasn't a database guy, it's not like he was just one random entrepreneur kid or something. He already had a bit of a track record in networking and hacking and security. But this is all stuff covered by the article. I do recommend you check it out. I think it's a pretty interesting read. So I mentioned that I would give you an introduction to Redis. So let's do it. I won't be able to cover everything, of course, in this presentation, but it's just to give you an understanding if you always used Redis only as a cache through a library and never had the opportunity of playing with it. So if you open Redis CLI, which is the program that I have open here, I'm going to open it again. Redis CLI. I have a running Redis server inside Docker, so I can do ping and I get a reply coming back. It's just a way to know that we are actually connected to a running server. And so what's the data model in Redis? Well, how do you interface with Redis? With Redis, the base building block of the language that you use to speak with Redis are commands. So commands usually start with something that you want to do, for example, set. And then you have a key, for example, that could be, I don't know, my key. And then you set it to a value. Hello. So now I set the value to my key and I get OK back. I can also get the key back. And I get hello back. Now that's easy. And also kind of boring. I mean, simple string keys are kind of boring, but this is the nice thing about Redis. Redis is usually presented as a key value store, but whenever you talk about key value stores, except of Redis, key value stores usually have keys that are strings, use a string to specify the name, and then the value is always a string. But with Redis, that's not the case. We have those, but there's also, you can also have a different type of key, for example, a set. And you can use set add to create a key, my set, that contains, I don't know, A, B, C, D, A, B, D, C. Well, and then you can do S is member, my set, B. Did we put, so this is another command that is able to ask a set key if one element is part of it, and the answer is 1. What if I try to ask if X is part of the set? I get 0, which is false. So you can see that this is not a string anymore. This is a set data type. And the interesting thing is that this is not just syntax sugar. This is like the key behind the scenes is implemented as a hash map. While this is just a byte array, this is a full-fledged hash map. There's also sorted sets. There's lists, and lists are doubly linked lists, and a few other data types. So, and for each of these data type, you have a set of commands that can manipulate it. So if you go to redis.io, for example, you can see in the command list that there's all the different things that you can do with Redis. So you say, oh, I'm interested in, let's take a look at sorted sets, or actually, let's take a look at sorted sets. So sorted sets are like sets, except that they keep ordering, and you can give a number to each element, that a score that corresponds to that ordering. And these are used for video game leaderboards and stuff. Then there's, let's go back to sets. So sadd, that's the command that we use, allows to add a member or more to a set. Then you could do set difference, intersection, get all the members of a given set, move a member from one set to another. And it's nice because that's an atomic operation that allows you to move a member from one set to another. And so there are all these commands that do very specific things. And that's how you interface with Redis, generally speaking. So what I showed you is the command interface. You've seen that the general structure is you have a command, you have a key. You could specify more than a key. For example, smove takes 2 keys as input, source set and destination set. But in the simple case, it's just, let's say it's just 1 key and then a bunch of arguments. So I'm going to show you now a few other commands. And what I want to show you is how this base syntax, this base way of interfacing with Redis can also properly implement and express very wildly different ways of interacting with the database, which is why I'm then, which is the one of the starting points from which then Redis is able to allow to implement a real multimodal database, but we'll get there. So this is one command, ts.range, and ts stands for time series. And this would be a command that allows you, given the text in red is the key name. This command allows you to get a range from a time series key, and plus and minus are start and end. So this means basically everything that's inside the key, but this could be, but you could replace minus and plus with like timestamps, and then you would be able to restrict a little bit the query. And then on that, we want to run an aggregation. We want to run an average aggregation using 1,500 millisecond big windows. And here we have expressed in I think a reasonably clear way what we want to do on a time series key. Of course, Redis doesn't have a time series type. Redis has sets, sorted sets, a few others, but there is no time series type. Now let's take a look at this other query. Graph.query, then you have a key that should contain your graph. And on top of that, we run what you're seeing between the quotes, that's a full-fledged Cypher query. And that's the same query that you would run on Neo4j or another graph database. And it works because the whole query, even though that's a language nested inside the query language of Redis, the query language of Redis is not particularly complex. So all we had to do is bundle everything as a single string. But then we are able to run graph queries on a key if we had a key of type graph. Full text search. This is a way of running a full text search query on top of a full text index. You can see the syntax is not the same as the one from Elasticsearch, but again, it does kind of make sense, right? It seems fairly clear that you, at least at the level of the syntax of the command syntax, all this stuff is doable. Now, when you think about SQL or even MongoDB, you're not usually just running simple commands. You're not just doing one thing with your command. Usually what you're doing is stringing a bunch of operations together. You start by select, then you apply some changes, then you do a join, then you at the end apply a filtering where constraint, and you do all this kind of stuff. So how do you do that in Redis? And what I just described is SQL, but you also kind of do the same in MongoDB. In MongoDB, it's less, it's more unstructured what you do, given the fact that objects have nested properties, you have lists, arrays, and stuff like that. So how do you do this stuff in Redis? The answer is that in Redis, you don't really do that. This is super weird for people that are not used to this, for people that come from more traditional backgrounds. But I assure you, I understand your pain on one end, but on the other, you don't really need to do that. The idea behind Redis is that you do not store everything as a normalized set of tables, and every single time that you want to have a response to a request, you compute from scratch the response by grabbing stuff from different places, potentially making the computation faster, more efficient with indices. No, with Redis, your data is stored denormalized in Redis, and it's not only denormalized, because you heard the story of denormalized data also from MongoDB, but also in MongoDB, you still want to do this stuff. The difference is that MongoDB, it's only giving you one data type, the document data type. And yes, you have properties, you can have numbers, you can have dates, you can have arrays, which is nice, and an object nested in arrays, sure. But that gives you a little bit more freedom in terms of structuring your data. But this is not this is like a few steps below what you get with Redis, because with Redis, you get sets that are hash maps, you get lists that are linked lists, there are sorted sets that are implemented as trees, etc., etc. So the data types are much more specialized in Redis. And you have many more, and each of these data types gives you a lot of commands. So the long story short is that in general in Redis, you end up always only running 1 or 2 commands and then maybe applying some changes on the client side. You don't really do a lot of work inside Redis. This is a general idea. So most of the time, there are enough commands so that you can make do with 1 command, but this doesn't cover 100% of the cases. For the few cases where you really need to do something more complex inside Redis, you can use Lua. And Lua is a programming language, it's a full-fledged programming language. So you send a Lua script to Redis, and Redis then runs the Lua script, and the Lua script is able to run the same commands that you will be able to run from the client, but then it's also able to, read the reply, do branching, while loops. It's a full-fledged programming language. So in Redis, you have, let's say, 2 levels. The normal level, which are single commands. Then we skip the intermediate compose a query and run it every time level. And then we jump directly into full-fledged programmability with Lua. That said, if some commands require some degree of, like, for example, I showed you the example of a full text search query, but for full text, it makes sense to run some, optionally some aggregations for faceted search, for example. That's all fine, because that's supported by the command itself. It's the full text search command that gives you the option, has support for arguments that specify an optional faceted aggregation, for example. It's not something that is global within Redis. Now, the forced simplicity of the commands interface is very nice because allows you to then implement some kinds of extensions in Redis that you would not be able to have otherwise. And those are Redis modules. So the commands that I showed you before, yes, they are not data types present in Redis, but they are things that you can do in Redis by loading a custom Redis module. So the way this works is that Redis has an internal C API that allows you to load dynamically modules written in C. So these are basically C# shared libraries. And your module has a way of registering new commands inside Redis and also registering new data types. And registering new data types is very, very important because again, if you are implementing a search module, of course, your search module has to be efficient. I would say, generally speaking, but also especially since you are writing a search module for Redis. And in Redis, the expectation is for stuff to be fast, generally speaking. So, for example, the full text search module is called RediSearch, and that module implements an inverted index data type. There's also RedisGraph, which is the graph module that allows you to create graph keys, and the data type implemented by RedisGraph are sparse matrices, and then Graph is able to use a library called GraphBLAS to run matrix operations on compressed sparse matrices, and that's pretty cool because sparse matrices are way faster than the other representation for graphs, adjacency lists. And that's something that not many graph databases do. And so modules, they are not really just an excuse to add more stuff on top of Redis, but they really make sense in the ecosystem because you are able to bring in your data type and to be fully precise, bringing in your data types means really that you can bring in your own C structs. You can use pointers. There are other databases that give you a form of multi-model interface. I'm thinking, for example, of FoundationDB, which is a great project. I love that project for many reasons. But one gigantic difference is that FoundationDB has what they call layers, and they have a layer that gives you a MongoDB interface, another layer that gives you a graph database interface, etc., etc. But at the end of the day, everything in FoundationDB is implemented on top of simple byte arrays. So you won't be able to have the performance. You will have the interface, the syntax sugar level, I guess, of a graph database maybe, but you won't be able to have the performance characteristics of a very optimized graph database. While here with Redis, that's part of the main philosophy of Redis. You never get only the interface. You get the interface, but also the performance and asymptotic complexity characteristics of a given data type. So let me quickly run through all the different data types. So there's also probabilistic, which is the Redis Bloom module, which implements Bloom filters and cuckoo filters and a few more types. Document allows you to store JSON data in Redis, not as a string, but as a tree of nodes with pointers, which makes updating and manipulating the data more efficient than it would be if you were just to toss a serialized JSON file object inside a string key. There's a module that allows you to run TensorFlow models and also Onyx. There's another module called time series, Redis time series, that we saw an example command earlier, allows you to store time series in Redis, and they're very compact, and they give you the aggregate, the opportunity of aggregating data, downsampling, et cetera, et cetera. So each of these is interesting in its own right. That's what I'm trying to say. If you go to redislabs.com/modules, you will find the ones that are maintained by Redis Labs, so the ones that you can get also, commercial support for. While if you go to redis.io/modules, you will find also the ones written by the community. There's also one written from me there. So I showed you, actually, before we go into transactions and Lua, let me show you one example running for real. I mean, I showed you the slides, but I think it's interesting to see this stuff actually run. So let's go to RedisGraph.io. Here you will find, instruction on how to download the module, how to make it run. There's a few examples. So I'm copying one example, copy, and I'm running it in my console. And the command succeeds, and we get labels added, node is added, properties set, bunch of information. Cool. Now there's a program called Redis Insight, which I think it's localhost 8081, right? Yeah, I closed the tab by mistake. So if you open Redis Insight, that's a graphical tool to take a look at what's in your database and etc. There's my set, my key. These are the two keys that I created earlier, right? And then also the MotoGP key. But the MotoGP key is of a different type. So we can go to the Redis Graph interface to take a look at it. And if I do match, this box takes a Cypher query. So if I do match X, return X, then I can see all the stuff that I added with my last command here. I added Valentino Rossi for Yamaha, Dani Pedrosa, Andrade Vizioso. And you can see that it works. There you have it. So, and this is really fast because it's based on sparse matrices. So this stuff is real. That's what that's what I'm trying to say. So let's talk about transactions. I mentioned not only multi-models, but atomic transactions across different models, right? So we are finally getting to the core, the meat of this presentation. So, all right, first of all, transactions in Lua are not super trivial. To really know how to use them, you won't get out of this presentation knowing how to use them in detail. I will give you a very high-level overview. But if you want to learn more, so if you're intrigued and want to learn more, you can go to redisconf.com. We held an online version of RedisConf a couple of weeks ago, and there's still training up there. I specifically run the training for transactions in Lua, so you will go there and you will be able to learn a bit more about this stuff. So it's going to be up there, I think, for a couple more weeks, if you're interested. So what you're seeing now, so up until now, we saw individual commands, and commands get always sent one by one. But here, what I'm showing you is two particular commands, multi and exec, or multi. I don't know, I usually pronounce it multi, but multi is the command that starts a transaction. Exec is the command that commits the transaction. So here, what we are doing is basically say, start a transaction, then run these three commands, and then commit it. And these three commands, as you can see, they, from the point of view of Redis, they are just commands. Redis, at a high level, to make this work with transactions, doesn't really care about what the commands do. So the first command is adding a value to a set. The second command is incrementing atomically a key. Well, it would be an atomic increment even if it weren't wrapped in a transaction, but but it's also in this case. So then, and then the third command is just running a query on a graph. And I just left ... instead of writing any Cypher query. But you could see how this would be 3 updates that basically you want to say, okay, Marquez won a championship, so we are adding points to him, setting him as, adding him to the set that contains all the champions, and then I'm going to update my MotoGP knowledge graph. And this, being wrapped in a transaction, has all or nothing semantics. So other concurrent clients won't be able to see intermediate states. You know, everything that you would expect from transactions, you get it. And here you can see how this can, at the query language level, you can see how, well, command language level, you can see how these can very easily interoperate with custom types, custom behavior, custom models. The same also is with Lua. So with Lua, you can do even a little bit more. What you're seeing here is more or less an equivalent Lua script that does the same thing that we saw in the previous slide. So we are calling, so the first 2 lines is just me assigning arguments that we are given as input to the Lua script to local variables, so that the script becomes a little bit more readable. But then I'm calling add, and then I'm doing the increment I'm incrementing the points. But here, just to show you that you can also use if and other control flow stuff from Lua, I'm showing you that if the points that we give as argument to the script to increment are equal to 0, then we run the incur by command. Otherwise, we don't run the incur by command, but we just get the current value so that we can store in a local variable total points, how many points we have. And then we call the graph query, and then we return total points, because one thing that Lua scripts can do is not just apply side effects to Redis, but they can also compute and return values to you. So there are situations where you might prefer a Lua script, other situations where you might prefer a Redis transaction. There are differences between the two, but at a high level, both give you the all or nothing semantics. And these are run in a full serializable isolation level every time. And yeah, and they're really nice to use. Now, the next question that I usually get is, well, okay, so you can run transactions, that's nice, but Redis is in memory, so it's not persisted. So why I can't really do anything with this stuff at the end of the day? Well, the answer is no, there is persistence in Redis. And you can enable it very easily. And it works like it works in any other database. Just like every flower is a rose by another name, every persistence model is fsynced by another name. So the way it works in Redis is that you have RDB files that are full database snapshots that get taken at a frequency that you can configure. So I don't know, every minute, every 30 seconds, you can configure it. But so what about between one snapshot and the next? Because snapshots are a little bit more expensive, to create. So you can't create a new RDB snapshot every time you have to run one command. And this is where the AOF file comes into play. AOF stands for append only file, and that's the commit log of Redis. So whenever you run a command, it gets immediately appended to the append only file. When you shut down Redis will and boot it back up. During the boot sequence, Redis will reload everything that's inside the RDB file, and then reapply in sequence all the commands stored in the AOF file. So this basically brings everything to the most current state. And the AOF file gets trimmed every time you take a new snapshot, because some of the stuff stored in the AOF file becomes not useful anymore, right? Because the changes were already reflected in the more recent snapshot. So that this is how everything works. And this is more or less what you get from other databases. It's the same type of tweaks that you can do, for example, with Postgres. One interesting thing about persistence and transactions is that transactions stored in the AOF file also start and end of a transaction, which means that if for some unfortunate reason somebody pulls the plug from your machine running Redis at the wrong time, and only part of the transaction gets flashed to disk, Redis will see that there is a transaction that is opened but never closed, and the AOF file ends before the transaction is closed. And at that point, Redis will notice this and simply discard the entire transaction. So it will not apply a partial transaction. It's annoying because you are losing a little bit of state, but that's inevitable. I mean, when stuff like this happens, you always lose something, regardless of which technology you're using, because some commands were still in the client buffer, some other commands were halfway through the network. And so the important thing is that you don't restart with a completely inconsistent state. And that's why you really want to drop partial transactions instead of applying them partially. The same mechanism also works with replication. So replicas, when they are applying changes from reading changes from a master, they also will not apply partial transactions in the case that they are replicating the master, but the master dies halfway through. But that said, Redis is a high availability system, so replicas synchronize replicate asynchronously from the master. So you could have that if you have a lot of writes to the master and then the master dies and a replica gets promoted to master, the replica might not be up to date to the latest state in the master. But that said, the replica will never apply partial transactions. So it's a long story short, it's a reasonable HA system, not ACP1. There's a module for Redis called RedisGraph, which was announced as RedisConf, which is a module that uses all the cluster bus communication mechanisms to implement Raft on top of Redis. And if you use RedisGraph, well, in the future, once it gets published and gets out of alpha state, then you will be able to have better guarantees, of course, at the expense of performance. So this, I think, is a full overview of what you can do, almost full overview of what you can do with transactions. There's one last important detail, which I cover in this article. Transactions in Redis do not support rollbacks. And if you've always used SQL, this might be surprising, scary, maybe disappointing. But I guarantee you, you don't need rollbacks with Redis. That's what I try to argue in this article. So to give you a very extremely compressed overview and summary of what I wrote in the article, rollbacks are a great idea. They're very useful. They are very nice in a SQL ecosystem, not necessarily only SQL, but in ecosystems that work with similar assumptions to the ones behind SQL databases. So big projects, everything is multi-threaded. But rollbacks are not free. Rollbacks take memory, right? To be able to roll back, you need to keep the old copy of stuff and the new copy, and then you only merge the two once you commit. There's no other way of doing that. And Redis is much more performance conscious than other databases. And also Redis is used very often under levels of pressure that other databases just cannot sustain. So Redis does not implement a rollback mechanism. And if you've always programmed using SQL, for example, then you might feel a little bit lost because you've used to the idea of I open a transaction, I lock a few rows, I get some orders, think about it on the client. So I do apply some changes, then maybe I try to do something that violates a constraint and the database rolls back the transaction for me, or I decided to roll back because of application level constraints. Yeah, fine, that makes total sense. In Redis, you would not write a transaction that way. The full story, the long story short, is that with Redis, you have to use a different transaction style. And in part is also because Redis is not a SQL database. I said that already before, but your gigantic store procedure that runs across, I don't know, tens of data tables and does a lot of very complex stuff, you wouldn't do it the same way in Redis. Redis is denormalized. Everything tends to be like the data models tend to be simplified by design before you put them into Redis. So long story short, not having rollbacks doesn't preclude expressivity. So Redis transactions are as expressive as SQL ones. Yes, sometimes having rollbacks would be nice, but they are not free. And every reasonable SQL transaction can be translated to an equivalent, functional equivalent Redis transaction. If your query is super complicated, there are a lot of steps, then it might not be practical to do so, which is fine. But the idea is that the general design principles behind Redis. So if you're using Redis the correct way, you should not be trying to do that anyway. And yeah, that's a very important characteristic of multi-exec transactions and also Lua scripts. So I encourage you to read this article if you want to learn more. Now, one data model that is part of Redis that I didn't cover for up until now are Redis Streams. Let me see how I'm doing with time. So, yeah, we are almost. Sorry. Okay, I'm doing fine with time. So I won't be able to introduce Redis Streams in full, but again, there is training for Redis Streams at redisconf.com. There's also documentation on redis.io. And actually, I will show you a little bit about Redis Streams. So there's support for Redis Streams in Redis Insight. And you can think of Redis Streams as a log data type. Actually, let me just bring up the definition from the slides. So Redis Streams are an event log data structure in Redis, and they support pub/sub fanout and consumer groups. You can think of them as a lightweight Kafka, basically, inside of Redis. If you go to redis.io in commands, you will find there's also streams. And here you can see all the commands that you can use. And yeah, they give you basically what you get also from Kafka. But more lightweight, no zookeeper, no Java, no garbage collection, stuff like that. And if you go to the documentation, you can also find introduction to streams. Where is it? Introduction to Redis Streams. Here it is. So you can find the intro to streams that explains to you how to use streams, the basic commands, the way IDs work, how to get data, and how to use consumer groups to parallelize computation across multiple consumers. That's another very important feature. If you want a super quick and dirty, so if you've used Redis pub/sub in the past and you always said, oh man, I wish I didn't lose messages whenever I disconnected from pub/sub, then Redis Streams are an answer to that question. And what's interesting about Redis Streams is that by being a commit log, basically, data type, well, that can be used as a commit log data type inside Redis. If you pair streams with any other data types, what you get is basically a very nice way of implementing sagas, of implementing many distribute transaction-ish patterns that end up really annoying to implement otherwise. So not only you can have like real atomic consistency, like atomic transactions using multi-exec, but you can also implement on top of Redis a different way of transactions that are implemented as multi-step operations, like what basically sagas are. And the way you do this is, for example, you can see here an example where I'm saying, well, if somebody put inside the stream an event, and to process that event, I need to write something inside a graph database, and maybe you also need to do something else. All changes that you need to apply to process an element of a Redis stream, you wrap everything inside the transaction, inside a multi-exec transaction, run the 3, 4, 5, whatever commands you need to run to apply the changes, which in my case, maybe I have a MotoGP event that asks me to do some change in my knowledge graph and something else. And then atomically, I also mark the entry as completed using exec. Exec is a command used by consumer groups to say, to notify to the stream system that a task was completed, that an entry inside the stream was properly processed. And that way you can build very, very advanced architecture. And it's very simple to deploy Redis. It's very simple to debug. You have a lot. It's easy to inspect what's the state. Doing this stuff with other systems, I mentioned Kafka, but I'll stop there. But Kafka is not the only one system that is not always the easiest to operate and have introspection inside. With Redis, all this stuff is very easy. And all these models, they also make use of all the tools that the Redis ecosystem gives you. I mentioned transactions, but they also work with clustering and replication and more. So it's very nice, I think, once you get a little bit of understanding of the ecosystem and to be able to have this much power at your fingertips. I think I just want to say one last thing. So let's say that you are intrigued by what I presented to you a little bit, and you say, well, how do I convince other people to try this crazy thing? How do I convince them to use Redis as something other than a cache? Because, of course, it's understandable that maybe managers and other stakeholders don't want to jump into a new technology. Well, the answer is that if your company understands what sqrs does, try to position Redis as a good store for storing sqrs views. For everybody else, for who doesn't know what sqrs is, sqrs stands for command query responsibility segregation. But the idea behind sqrs is basically that instead of whenever there is a view that like if you have a SQL database and you had a view that requires you to show a summary of your data, you would maybe write a complex SQL query that aggregates everything and produces in SQL the summary of the data, and then you run this every time and return it to the client. When you are applying sqrs, you think about it the other way. You think about the queries that you have that want to see a particular view of your data, and you prepare those and you update them every time you make a change to your main data. So that summary view would basically go inside Mongo or another database and just fetch the already prepared answer that gets updated every time your source of truth gets updated. And so that data is basically data that you can lose. If you lose your sqrs views, you can just rebuild them from the original data. And there are many good properties. There are a few things that you gain by doing things this way. So sqrs is just a way of giving a name to this practice in a particular way of developing applications. And that's why Redis, and that's what Redis is the best at, because the idea is that your data should already be mostly in the shape that you're going to need it. So I think that if you read about it, read a little bit about sqrs, you will be given a good understanding not only of from a computer science point of view of how things could work in an efficient way, but also you will get an understanding of how you can position this in your company and how it can make sense in your development process, basically. That's, I think, the end of my story. So I guess if anybody has questions, I'm happy to answer them.